Okay, so question 4 is to do with functions, ranges, domains, inverse functions, etc. So the first part for 2 marks was to state the range of this function here. And what a lot of us did was we substituted in 0 and found that f of 0 was 0, and we stated therefore that the range we thought was f of x bigger than or equal to 0, which will, doing that part, will probably get you just 1 mark. There was another part you had to do, and that's to consider what happens if x tends towards infinity. So as x gets really big, you've got to think what happens to this function here. Now it actually has a limit on it, and what happens is this 12 and this 3, they're impacted by x, whereas this 4 becomes less and less and less important. So if you imagine x being either a million or a billion or a trillion and carry on going like that, what happens is this tends towards, if I go f of infinity, this will tend towards, it doesn't actually equal it, becoming just 12x over 3x, which tends towards 4. It will never actually reach it, and if you try bigger and bigger numbers in your calculator for x here, you'll get answers kind of becoming like 3.9, 3.999, 3.99999, and so on. It will never quite reach 4, and what that means is that the range of our function is bigger than 0, but still less than 4. So on this kind of question you have to think, yes, the limit they've given me, but also what about if x tends towards infinity, or if it was allowed to minus infinity, but in this case just infinity. Now part B wanted us to find, and it was written like this, f minus 1 x. And this is where a lot of us made quite a basic error. So this question is not asking you to differentiate it. Okay, if it wanted you to differentiate, that's f dashed x. There's a very slight difference in the notation there. So f minus 1 means the inverse function. And this is the one where you say, okay, let's make it y equals 12x over 3x plus 4. And we're going to try and rearrange this equation here to make x the subject. So multiply the 3x plus 4 is 12x. And I'm going to attempt to rearrange this to make x the subject. So 3xy plus 4y equals 12x. I've got 2 x's, so at some point here I know I'm going to have to factorise. So let's get them on the same side. 3xy minus 12x equals minus 4y. X lots of 3y minus 12 is minus 4y. And I'm about to run out of space, so I'll go back on the other side. So from there, I end up with x equals minus 4y divided by 3y minus 12. Okay, now that looks fine. If you leave it like that, again, you're going to drop a mark because it wants you to say what f minus 1 of x is. Now, f minus 1 of x therefore has to be the subject of my equation. And what you have to remember is that these y's here, you need to swap them back for x's. And so you get minus 4x over 3x minus 12. You might have the negative version of this, you might have 4x on the top and either minus 3x plus 12 or 12 minus 3x on the bottom. That's absolutely fine as well. All that happened there is that over here you move the 3xy to the right hand side instead of moving the 12x to the left hand side. Both are absolutely fine. Okay, part C. Show that f of x, so we're attempting to show now f x equals 9x over 3x plus 1. Okay, now f x is, as most of us started off, taking this function and putting this function into itself again. So each x is going to get replaced by 12x over 3x plus 4. So what happens is we start off with f, so this is going to become 12 lots of, and I'm going to have to write the whole thing out, 12x over 3x plus 4, over 3 lots of 12x over 3x plus 4, plus 4. Now this is really difficult to do anything with. I absolutely cannot split this into 12 lots of the bracket over 3 lots of the bracket plus 12 lots of the bracket over 4. You cannot split a denominator like that. Okay, and that's quite a crucial error that some of us need to learn to avoid nice and quickly. So you cannot do that. The only thing we can try and do here is to get a common denominator on the bottom. So what I want to do is this 4 here needs to end up with a 3x plus 4 on the bottom. So what I'm going to do is in here, I'm going to have 3x plus 4 over 3x plus 4. It doesn't show up brilliantly, but I'm going to write it out again in a second. Now what this means is on the bottom here, I've got 3x plus 4, and I've got another 3x plus 4. So what I've got now, if I look at just this bottom line, that bottom line now, with a 3x plus 4 on the bottom, the top line has become 36x plus 4 times 3x plus 4, so that's 12x plus 16. Okay, so this whole bottom line here has now been replaced by 36x plus 12x plus 16. Well, let's change that to 48x. Let's just simplify that on the top. 48x plus 16. And that is now the whole denominator of the big fraction that we were working with, aiming to work towards this ffx here. I'm going to move back to this side of them for a second. Now, because we've got a fraction here on the top that has 3x plus 4 as its denominator, and we've got a fraction on the bottom that's also got 3x plus 4 as the denominator, they now cancel out. Okay, if you're not happy with that, think about division of fractions. Think about the fact that dividing by a fraction is the same as timesing by the upside down version. You'd have a 3x plus 4 on the bottom, and then a 3x plus 4 effectively on the top once you'd flipped it. So they will cancel out with each other. And what we're left with, therefore, is from the top line, we've got 12 times 12x. And on the bottom line, we've still got 48x plus 16, which overall is 144x over 48x plus 16. And everything there is in the 16 times table. So if we divide everything by 16, we get 9x over 3x plus 1. Okay, that's just simplifying that bit by dividing everything by 16. But the whole thing came from, right back up here, was getting this common denominator for the two terms that were on the bottom here. Okay, when we had the 3, and then the brackets, and then the plus 4, was to get the common denominator between them, was the only way we could go about doing this question. Now, final part of this question. Even if you had not managed to do part C, you could do part D. Because part D was about ff of x. And part C actually shows you what ff of x is. So even if you've not managed it, you can still use that ff of x is 9x over 3x plus 1, because that's given to us in the question. And the question is, show that this cannot equals 7 over 2. Basically show that this thing has no solutions. So the only way really of doing this, I would say, is stick these two things equal to each other and see what happens. We're assuming it's not going to work. So I'm going to say 9x over 3x plus 1 equals 7 over 2. Now if you do that, we're going to try and solve this. So I'm going to times the 2 up that way. I'm going to times the 3x plus 1 up this way. So I'm going to get 18x equals 21x plus 7. So that's moving the 3x plus 1 up to this side and the 2 up to this side. Now rearranging this is going to give me 3x on this side minus 7 there. And so we've got x equals minus 7 over 3. And right back at the very, very beginning of the question, the domain of the original part was defined as being x had to be bigger than 0, bigger than or equal to 0. So therefore this answer that we've just got absolutely cannot happen.